Okay guys, I want to help you set up with the new FRQ I'm going to drop for tomorrow. Okay, this is not exactly what the FRQ is going to look like, but it's to mirror something very similar to this. Okay, so this is a very simpler example because I don't want to go through so much because I don't want to waste your time too much with this. So I have to figure out what, for example, G of 0 is going to be. Okay, and so what is G of 0? Now G of 0, or G of x, I'm going to go ahead and call it that, is equal to the integral from -5 to x of f of t dt. Okay, so now why am I using f of t and why is it using g of x? This is what College Board likes to do. Okay, it's to confuse you a little bit, but the point is I'm integrating this function or this graph of the function based on what I have here. So g of x, or my x points here, f of t is this graph. So it turns out, just to give you a hint, that g of x is really equal to f prime of t. So it's really trying to tell you the distinction between these two different functions. G of x is just the derivative of f. Okay? So I'm going to also give you one more piece here. A equals 4. So I say to myself, how do I figure out this? Well, what I'm looking at is that 0 ends up right here. Okay, and notice that I didn't do much to tell me what's going on over here at this point, but you can kind of fill in the blank that this is -2 and then this is -1 the way I put it in here. Okay, so how do I figure this out? Well, I've got two things. I know that A equals to 4 between the interval of -3 and 0. So that's part of my area. Okay? And so if I look at this right here, if A equals, in this situation, I'm going to set up my integral as from -5 all the way to -3. Okay? So this is what it's supposed to be. The integral of -5 to 0 will be actually equal to this plus the integral of -3 to 0. Okay, and this is all going to say dt at the very end. Okay, dt. So what function do I have here? Well, in this case, I have a straight line, don't I? Right? And so this shape from -5 to -3 is really a triangle, isn't it? So I can just do base times height divided by 2. Remember that the integral is the area bounded between the x-axis and the curve, or the shape that I have here. So what I really have altogether, the integral from -5 to 0 of f of t dt would be the base of -5 to -3, which is 2 times 2 divided by 2. So this would be 2 times 2 divided by 2 plus, well, what's the area between -3 and 0? Well, that's A, and A is equal to, in this case, 4. To make this a little bit more kosher, I guess you can say, is that this should be negative because obviously this is below, right? So this would be -4. So doing all that without having to have any equation to integrate, it's just looking at the symmetry of my problem. I have a triangle from -5 to -3, and I have a parabola that goes from -3 to 0, but it's defined for me here as that area right there. So that should give you a hint. On the FRQ that's going to be dropped, you're going to see that there's going to be a lot more coming up over here, and they will give you one equation from one interval set to another interval set. Okay, so hopefully that helps you out there. The one thing that you'll be asked about is concavity. Remember that concavity is really the derivative of, in this case, g prime of x, or in this case, f double prime of t. So when I talk about where is it concave up or down, they're really looking at this graph here and seeing where, if it's concave up, where is it going up? From what interval to what interval? And if it's concave down, where is it going down? From what interval to what interval? Okay? And another thing too, when we're looking at minimum points or maximum points, minimum points start from when it goes from positive to what? Negative. Okay? So if I look at this here, it goes from negative to positive. Sorry, negative to positive. So in this case, my negative region is all right here, right? It's negative, negative, negative. When it hits this x-axis and it goes, let's say it were to go up over here, then it goes from negative to positive. That's a minimum point. Okay? Where else would there be a minimum point? And I'll leave that for you guys to figure it out from here. All right, good luck, guys.